We now move on to the second lesson of the second module. The module 2 is quadrilaterals, and now we will learn about parallelograms. The learning objectives of this lesson are to prove and use theorems about the properties of parallelogram and to prove and use theorems about diagonals of parallelogram. We will look into both of these objectives in this video, and the keyword is parallelogram. Now let's learn what is parallelogram. I'm sure by now you might have realized this something to do with parallel lines. And you can see a parallelogram is having opposite sides which are parallel. So this is the thing about parallelogram. You can see this line and this line is parallel, the opposite ones, and even the opposite over here are parallel. Now, here there is few things that is required to be known. If a quadrilateral is a parallelogram, then opposite sides must be equal or congruent. That means they are equal. And then opposite angles are also equal. So this is very important. Now this angle must be equal, and this over here equal. So now you might think, okay, this is a rectangle, is it? Rectangle is a parallelogram, but not all parallelograms are rectangle. What I mean by that is, what is a rectangle? It should have always 90 degree, right? And the opposite sides are equal, opposite angles are equal, yes. But the parallelogram doesn't mean that all the sides are 90 degree. This is a very important differentiation. Now, all the sides of parallelogram are not 90 degree. It might be in the case of rectangle, or it may not be. So this is the difference. And over here, another property is quadrilateral is a parallelogram, then the consecutive angles are supplementary. See, these three are important. I'll explain one by one again. Opposite sides must be equal. If this is phi, then this must be phi. Opposite angles must be equal. If this is 120 here, then this is also 120. And quadrilateral is a parallelogram with consecutive angles equal, supplementary, sorry. Consecutive means if I select this, next to it, if I select this and this, they're consecutive angles. They must be supplementary. If this is unknown x, I know when I add this x, it must be supplementary, that is 180 degree. Supplement, extra 180. Complement would be 90 degree. Now x would be 60 over here. That's the answer. This would be 60. So whenever you add 2, and if this is 60, then opposite is 60. And whenever you add 2 supplements, add 2 consecutive angles, they are always 180. And the last one over here, if parallelogram has one right angle, so imagine this is 90 degree. It's not, but just imagine for understanding sake. If one is 90, then opposite will also be 90, and then supplement must be total 180. That means all will be 90 and 90 and 90 and 90. So these are the properties, which is very important. And now let's use the properties and solve problems here. We have a parallelogram. They have told us to find CD, this side. The given side AB is 4. What is CD? It is equal. AB is congruent. This is the congruent, similar to equal. AB is congruent to CD, isn't it? That's the property of parallelogram. If this is 4, then that is also 4. So CD is 4 basically. That's the answer. Now let's see over here a check problem. Try this because this is a very simple, very easy chapter. Please do try this. Now they have given the measure of F and the sides. 2 sides are given. You need to find the measure of D. If this is 106, it's the same thing. This also is 106. And if this is FG, okay, opposite side is known. D is 8. FG is equal to 8. That's it. That is how we solve this. Very simple, very straightforward. Now let's see proofs. Okay, using proofs like the column proof. Now here we can see the figure. Write the correct statements and reasons to complete the 2-column proof. You can see H, J, P, K and ML in the figure, and they have told H, J, P, K, P is a parallelogram. This is the denotation of parallelogram, like this, okay? That's the denotation of parallelogram. Now all these means this is a parallelogram. Now P, K, L, M is also another parallelogram. Now what? They have asked you to prove HJ and ML are equal or congruent. This is congruent, not equal. It's same, but congruent means absolutely the same thing. Okay, if the angle is certain angle, that angle also is converted in this line. It's the same angle, same size, same length, everything is same. Now here, how do we do HJ and ML? Let's do the column proof first. We know these both are parallelograms. If these are parallelograms, we know the opposite sides are equal, right? So we know HJ and PK are equal, ML and PK are equal. Now you can see that PK is the same side. HJ, sorry, one second. Okay, this is now over here. Okay, HJ and ML. Sorry, you don't need to do that. I was thinking of something else. Now over here, it's very simple because they have just asked you HJ and ML. You just tell these are opposite sides of parallelogram, right? So we know this is equal to PK and PK is equal to here. Now PK is equal to these both. That means from transitive property you can tell HJ is equal to ML. This is like 1 equals, let's tell X equals Y and Y equals Z. So from this we can tell X is equal to Z. If X value is 3, then this is 3 and this is 3, this is 3. Then X and Z are equal. That's transitive property, right? So that's what we have done over here. It's a very straightforward one. I hope this is clear. It's all written over here. Now let's see another one. We need to do the 2-column proof. They have told JKLM is a parallelogram, and they have told KN and KL are congruent. Now look over here. This is a triangle formed, right? And this is equal to this. What does that mean? That means this is an isosceles triangle. We have studied it before in grade 9, term 3, I believe. Isosceles triangle means the sides, whenever the legs are equal, then these angles are also equal. Okay, that is the isosceles triangle, and then we know it's a parallelogram. So now if it's a parallelogram, then we know KN, okay, this is all given now, what is written. JKLM is a parallelogram, KN and KL are equal. That's given. So we have to write what is the reason, because it's given. Now next one, let's see what are the opposite angles here, because we have angle mentioned, right? We have to, find the angles, yeah. So let's see what are the angles equal. We can say over here, this angle and this angle are equal. See, J and L are equal. Why? Because they're opposite sides of a quadrilateral, isn't it? Now we are inching in closer. We have J over here. Now we should prove that L and N are equal. How do we prove that? Because if L and N are equal, then this is proved. Now we know L and N will be equal. We can't write directly L, we can, but usually we write KLN and KNL are equal. Why? Because this is an isosceles triangle, and from isosceles triangle theorem, it says that whichever, the base of the lines that are equal, these two angles are always, the legs angles are always equal. This is from isosceles triangle theorem. Now then, we know J is equal to L, is congruent to L, and L is congruent to KNL. That means from transitive property, we can equate J and KNL. This is from transitive property of I'm just forgetting the word. Okay, it's not equal, it is congruent. Okay, transitive property of congruency. So that is the thing. That's how we solve this problem. I hope it is clear. Now we will move on to diagonals. Now diagonals is something which is drawn across, say if this is something at the ends, which joins the two ends. Now if it's a parallelogram, the diagonals bisect each other. What does bisect mean? Now if this is a parallelogram, okay, this is a rectangle. Let me just draw a parallelogram like this. When we have two diagonal, now this is equal to this. Bisect means you're cutting something equally. You're bisecting a cake into exact halves, two halves. You don't use the word bisect for cutting a cake, but whenever you use bisect, that is with precision, equally half, 50%, 50%. That's what you're doing. Okay, and then if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into congruent triangles. Now one more thing. Okay, now here, if this is a diagonal, then this triangle is equal to this triangle. There are two triangles formed, right? They are congruent to each other. Now let's use the properties. Here we have a figure and they have told find the values of x and z. Okay, x is given over here and z is given in the figure. And in the ABCD parallelogram. Now measure of ADC. Can I see this? ADC is 4x. 4 and x degrees. And MD, measure of DAB. DAB, this one is 2x minus 6. So now we need to find x first. Let's do that. We know consecutive angles of a parallelogram are always supplementary. That means if I add 2x, if I add 2x minus 6 plus 4x, that will be equal to 180 degrees. Okay, now let me add 2x plus 4x is 6x minus 6 equals 180. Now take this 6 to the other side, it will be 180 minus 6. I'll directly write it 174. 6x and just solve it over here in the calculator and you will get the answer 31. Okay, just wait. Oh, sorry, I have done a mistake. Now this goes to the other side and I've added it. That's my bad. Minus 6 becomes plus 6. Okay, 186. Why? Because this minus 6 to the other side becomes plus 6, and 180 divided by 6. I know 6 times 30 is 18 and 0, 180, and add 1 6, it will be 31. Okay, 31 is the correct answer. So x is 31. Very straightforward. Or else you can just put this entire thing in calculator and you will also get the same answer. Not to worry. Now what about the next thing? We have over here the AE and EC. Now we should know that this is bisecting, right? These both are equal. So we can tell 3z minus 4 is equal to z plus 5. So what happens? The z goes to the other side, will be 3z minus z equals minus 4 to the other side will be 5 plus 4. 3z minus z is 2z equals 9. That is equal to 4.5. Z equals 4.5. Why? It will be 9 by 2. Answer is over here. Very simple, very straightforward. I hope this is clear. That's how we solve this problem with the properties of parallelogram. Now here we have a real world problem. Thomas is making envelopes to sell with handmade cards. He uses different style of paper to create the flap of the envelope and he edges the envelopes with washi tape. The envelope are parallelograms and the edges of the flaps lie along the diagonals of the parallelogram. Find the area of the flap and the perimeter of the envelope. Okay, so what he says, what they're saying is he uses different type of paper to cover only the flap. Flap is this covering part, you know, if this is an envelope. Sorry, that's very bad envelope. Now, can you see this upper thing which you tape it? Generally, we tape it over here. That he is making by something called washi tape. I checked online and I came to know it's like a glittering tape. This is called washi tape. It's like making beautiful. There are different versions of it. Anyways, this is just for simple understanding. And now here the envelope is a parallelogram. Okay, and then you can see the flaps that lie along the diagonal parallelogram and find the area of the flaps and the perimeter. Now can you see over here, this is also covered by the tape. So we need to know the perimeter. That means the tape will be covering the perimeter and this flap. So you have two things, two-part question. The first part is find the amount of paper required for this flap. That is, if you see carefully, this triangle is there, right? This is what you need to find. There are various ways to do it, but I'll do the easiest way possible. You know the area of a triangle is half base into height. What is the base? Base is this line, A to B. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, let's do it again. 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14. Now, why I realized I was wrong is because I was getting an odd number when I counted the first time. I got 15, which doesn't make sense. You can see they're equal. It's an equal line, right? And it starts from a corner, so it must be even numbers. Whatever is the number over here, it will be multiplied by that. Whenever you multiply any number by 2, it will be an even number. So that's why I realized 15 can't be true, so I counted again. So make sure you count it accurately. Now that is what? Base. Now what is the height? Height is over here. Let's count. 1, 2, 3, 4, 5. Multiplied by 5. Let's solve this. 2 1 time, 2 7 times. 7 5 is a 35. That is the answer. 35 unit square. Unit square. I don't know if it's centimeter. Okay, sorry, it's centimeter. It's 35 centimeters square. This is the area of the flap. That is the first part. Now that's the answer. But over here they have done different methods. They have found the coordinate midpoint, then added. You can do whichever method you like. It's all there over here. You can see it. But the easiest method would be directly counting it and finding the answer, because the answer will be the same. Doesn't matter which method you use. This is direct and easy method. Okay, this is the answer. Now let's go to the second part. That will find the length of the washi tape needed to cover the border, the ends, the perimeter. Now we need to find perimeter. What is the formula for perimeter of this is a rectangle, right? What's the perimeter of the rectangle? It's 2 times length plus 2 times breadth. What is the length? Length of base? We can count. We counted a while ago. It's 14. 1, 2, 3, 4, 5, 6, 7 times 2. It is 14. It is 2 multiplied by 14 plus, what is the breadth or the width? It's this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 into 10. So 14 times 2 is 28 plus 20. The answer will be 48 centimeter. Now it's not square, it's perimeter in terms of centimeter only. Area will be in terms of square. So the answer would be 48 centimeter. This is the answer. That's it. So anyhow you do, you will get the correct answer. So whichever is easy, just follow that, and that's how you can solve it. Now there's a check problem. Please do pause the video and try it by yourselves. Now this is a little bit tricky because you can't directly solve it. Now let's see how would you try and solve it. You can see over here they have told this coordinate is 0, 3, 3, 0, 0, minus 3, minus 3, 0. Now we need to, what do we need to do? Jemina is making a quilt. Each block of parallelogram made of single piece of pattern fabric is trimmed with a gray border. Find the area of the fabric used to make the block. Find the length of fabric used to make the border of the block round to the nearest. If I say, okay, we need to just find the area and the perimeter of this block. Okay, each block. How do you do this? So we need to find the area. One second, over here fabric made, okay, fine. Okay, yes, you need to find the area and the perimeter. Now to find the area of the perimeter, you need to find the side first. You need to know one side. You know this is 0, 3, 3, 0. You can use the distance formula and find it out. Distance is x2 minus x1 minus y2 minus y1. This is one thing. But the best, no, sorry, distance formula would be square root of x2 minus x1, and that's the thing. But the best and the easy way is, if you look over here closely, this is a Pythagoras theorem, right? Right angle triangle, right? This is right. Let me change the color. This is a triangle which is right angle over here. This is 90 degree. So we can use Pythagoras theorem. The hypotenuse C can be found out by the square of these two sides, root of the square of some of these two sides. In the sense, C square equals A square plus B square. Now we don't know the C square value. Let's keep it C square equals, what is A? You know, 0 to 3. This is 1, 2, 3 square plus, now this one over here, B is what again? 3 square. Take the square root of this. Square root of 3 square plus 3 square. This will give you the side, one of the side. Let's use the calculator. Square root of 3 square multiplied by 2, or you can, okay, this is the answer. Why did I do multiplied by 2? Because it's 2 times 3 square, right? You're adding 3 square 2 times, right? Or you should add it by 3 square again. Okay, it will be the same answer, 3 root 2. Okay, we got one side as 3 root 2, which is equal to 4.24. Now, how do we find the area? It's a square. See, you can see it's a square. Area is always area of a square is square this thing. 3 root 2 the whole square or multiply it with itself. Okay, that is the area. Area would be the answer, that is 3 root 2. Use the brackets. Square. What is the answer? It's 18. Area should be 18 over here. Yes, it's correct. And then what about the perimeter? Perimeter is 4 times multiplied by the side. Side is 3 root 2. You should just multiply it with 4. And now you will get it 4 multiplied by 3 root 2. Let's take the square off. It's 12 root 2. So that's the answer. Okay, over here it's written as 17. Yes, it's almost 17. Okay, that's the reason. 16.97, it's 17. So the perimeter is 17 centimeter. So this is how we can solve this easily. Now, there are other methods to solve as well. You can use the distance between these two. Now, if you, I will solve that one as well, that method. Now, what is this? You can take it as x1, y1, x2, y2. Okay, this is x1 y1 x2 y2. Now if you recall, we have distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square, this all square root. Now here you just substitute these values. You know, if you find Pythagoras theorem hard to find the side length, do this distance formula and now substitute the values. Square root, this is d equals, okay, distance is equal to distance or the side over here. Now what is x2? X2 would be this, x1 y1 x2 y2. It is 3 minus 0 the whole square plus y2 is 0 minus 3 the whole square. So you're getting same thing, root of 3 square and 3 square. See over here, square root 3 minus 0 the whole square plus 0 minus 3 the whole square. What is the answer? 3 root 2. The side will be the same. Then it's the same thing. What is the area? Area is this answer multiplied by the same answer itself. It's square, right? 2 times. That will be 18. Now that answer is gone because answer is changed. Now we'll take 3 root 2 multiplied with 4. It will be the perimeter. Now, sorry, 3 root 2 it is. That will be the answer. Always I'll just write the area equals side. I'll write side multiplied by side, whereas perimeter equals 4 times side. Or you can just add it 4 times, 3 root 2, 3 root 2, and that's how we get it. So this is how we solve this problem. Plenty of ways to solve it. And that's it. That's the end of this lesson. A simple and easy lesson on parallelograms. Please do watch it again if you get stuck anywhere. And if you have any doubts, please do put them in the comments. And I will try to get back as soon as possible with the next lessons. Bye-bye for now.